Is on exercise 1C questions 5 and 6 of A-Level Further Maths Core 1 textbook. Question 5. Express 1 plus I to the power of 6 in the form a minus bi, where a and b are integers to be found. So the most obvious way of solving this problem is just by expanding six brackets of 1 plus I times 1 plus I and so on. So while that's correct, it's not the best way because that's going to be a waste of time. So from pure 1 chapter 8, which is on binomial expansion, we can use the binomial expansion, and so we have a form which is a plus b to the power of 6, and in this case we have a to the power of 6 plus 6a to the power of 5b plus 15a to the power of 4b squared plus 20a cubed b squared plus 15a squared b to the power of 4 plus 6a to the power of b to the power of 5 plus b to the power of 6. Now how can we use this? So it's very simple. We can so let a be equal to 1 and b be equal to I. Now the rest is very simple because that's just a matter of substituting 1 and I into here. So now let's do that. We are going to have 1 to the power of 6 plus 6. So let's write that like this: 6 times 1 to the power of 5 times I plus 15 times a to the power of 4 times I squared plus 20 times 1 cubed times I squared. Oops, I've made a mistake here while I was writing this, because here should be b cube. So yeah, we will have also I cube here, not I squared, because we've already had that I cube. So that plus 15 times 1 squared times I to the power of 4 plus 6 times 1 times I to the power of 5 plus I to the power of 6. And it's worth mentioning that let's write that here. So as I show you in the previous video, I to the power of 1 is just I. Then I squared is I times I, and we know that that is minus 1. So I cubed is I squared times I, and we know that I squared is minus 1. So minus 1 times I gives us minus I. I to the 4 is I squared times I squared, which is minus 1 times minus 1, and that is 1. And interestingly, from I to the power of 5, this 4 cycle is going to repeat again. So I to the 5 is I times I to the 4, and we know that I to the 4 is 1. 1 times I is I. As you can see, I to the 5 is the same as just I to the power of 1. And I to the power of 6 is simply the same as I squared, and that is minus 1. So the reason I mentioned this is because we are going to use this in this question and even for the next one. So now we can simplify this. 1 to the power of 6 is 1 plus, so here we have 6 times 1, which is 6. 6 times I is 6i. Here is 1 times I squared. I squared is minus 1. So inside this bracket is minus 1. And minus 1 times 15 is minus 15. And here we have 1 times I cubed. So I cubed is equal to minus I. So that will be minus 20i. Now here is just 15, because 1 times I to the power of 4 is 1, because I to the power of 4 is 1, and times 15, it gives us 15. Now this bracket, so I to the power of 5 is equal to I, and plus I times 6 is 6I, and finally I to the power of 6, and that is equal to minus 1. So we have positive 1 here and minus 1 here, which adds up to 0. And we have 6I plus 6I here. So before going to the imaginary part, let's first check the real part. So we have minus 15 and plus 15, which is equal to 0. Now we have 6I minus 20I and 6I. So that's 12I minus 20I, and that's equal to minus 8I. And that's the answer. So this is probably the fastest, not the fastest way, because we will learn a much more better method later on, but for now this is the fastest way that we can do questions like this. Question 6, find the value of the real part of 3 minus 2I to the power of 4. So this is very similar to the previous question, and so the difference is that, first of all, the bracket is raised to the power of 4, so we need to use the binomial expansion of 4, and that is equal to a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed again. Not again, but this is very similar to the second term, but they're different, plus b cubed. And now it's it's exactly the same as the previous question, so we can start by writing that let a be equal to 3 and b be equal to minus 2i. Now we have 3 minus 2i to the power of 4, so it's just going to be the matter of substituting these values into here. And remember that we want to find the real part, so we start by writing 3 to the power of 4 plus 4 times 3 cubed times minus 2i plus 6 times 3 squared times minus 2i squared plus 4 times 3 times minus 2i cubed plus b cubed, which is minus 2i cubed. Right, so 3 to the power of 4 is 81. Now inside this bracket we have 27 times minus 2i, which is minus 54i, and 4 times 54 is 216, so we get minus 216i. And here, so we have 9 times, so minus 2i squared. Be careful, because in this one we get actually so minus 2 squared is 4 and I squared is minus 1, so minus 1 times 4 is minus 4. So 9 times minus 4 is minus 36, minus 36 times 6, and that's minus 216. Minus 216. So for this bracket, we have 3 times minus 2i cubed. So minus 2 cubed is minus 8. I cubed is simply minus I. So minus I times minus 8 is 8i, which is 24i, and that times 4 is 96i. And finally, the last one, which is minus 2i cubed, and that is equal to, again, minus 8 times minus I, which is plus 8i. Sorry, here should have been b to the power of 4, not b cubed, which changes the last bit, which is minus 2i to the power of 4. And as a result of that, we get 16, because I to the power of 4 is just 1, and minus 2 to the power of 4 is 16. So the real parts are 81 minus 216 and 16, and if we add them all, we get minus 119. And for the imaginary parts, which are minus 216i, positive 96i, we get minus 120i. And this is the answer, because this is the real part. So that's it for this video, and thank you for watching. Make sure to subscribe for more videos. Good luck.